Hi, everyone. Thanks so much for joining. Can y'all see my screen, the presentation, or do you guys see my script right now?
Yep, everything's good.
Awesome. Thank you, May. So, hi. Thanks so much for joining us. Happy New Year. This is the monthly Women in GIS Lightning Talk series. Every month we have a different talk. For the new year, we picked climate change as the topic. I am your host, Madison Bradford. I'm a professional development committee member and a data scientist for Gilbert, Arizona. Thank you so much for joining us. I just want to remind y'all that anyone can present for the Lightning Talks. Just because we're a women's focused organization does not mean that we don't accept people of all genders. We're also an international organization, so we tend to have speakers from all around the world. I want to give a quick shout out to some of our sponsors. Women in GIS could not put on these talks without the help from them. Our platinum sponsors, big shout out to our platinum sponsors, Esri, Bad Elf, and Embedded Alliance. We have a lot more sponsors as well, so big shout out to our gold and silver sponsors. And I want to give a special thanks to our brand new sponsor, DRT Strategies. So this is the first month of Lightning Talks that they are helping us out with. So we have a great lineup for today's presenters. Sadly, Mohammed Samir won't be joining us today, but in order of presentation, we will start with Wanmei Liang. Her topic is mapping heat waves with NASA GEOS 5 data. Next, we'll have Suneet Manjavkar. He'll be talking about GIS to enable climate change interventions. And then we'll have Brian Tucker, who will talk a little bit about being a global forest creator. So thanks so much. I want to remind my presenters that you have about 10 minutes to talk, and I will unceremoniously remind you at 9 minutes, so you may get an interruption if you're starting to hit time, and that basically means you can begin to wrap it up so we can move on to the next presenter. All questions will be saved for the end, but we'll have a brief Q&A session so we can learn a little bit more about your talks. So without further ado, we can definitely get started. And this will be recorded, but our first presenter will not be recorded. So we'll just pause right before her introduction.
Thank you so much, Madison.
Yeah, thank you. So very excited for our next presenter. Remember, if you have questions for Wanmei, make sure to save them for the end and feel free to pop anything in the chat. If you don't want to ask, I can ask questions for you as well. Our next presenter up is Suneet Manjavkar. So Suneet is a technology enthusiast with extensive experience in engineering-based technological solutions used in water, sewer projects, and currently rendering services in climate change areas. So you can go ahead and take it away, Suneet.
Can you see my screen?
Not yet.
Now?
I still can't see it. That's the
You
same
need
for
to
everyone.
share it, Suneet.
Yeah, I've done that.
Yeah, now we can.
We can see it now.
Oh, thank you. Yes, thank you for this opportunity. And I'm Suneet. I'm representing the History India. Topic is how GIS is the key enabler for the climate change interventions. Yes, we are doing the amazing things with the geography. And as we move, so what we do and what's the purpose, what we're doing it is enable, use of this geography, solving social, environment, and business challenges, and helping users to actually unlock the full potentials of multifaceted climate data. Climate is a spatial issue and which has inherently a link with various aspects from social, economic, natural, capital assets. And while we're working on climate change, what we are looking at is what is likely to happen, who and what will we get affected, when and where, and ultimately, what are the implications of the cost of actions and inactions. And that's where the GIS going to play the key role for tomorrow. While addressing the climate change, the geography provides science and technology to organize and integrating, reflecting on the complexities of our world, eliminating the patterns, discovering the relationships, and ultimately, these data-driven actions will support the climate mitigations and adaptations for future. While we working on the GIS-enabled approach for the climate change, what did actually help us to take the 5 major steps towards the climate resilience? First is to how to understand the exposures from the various hazards like heat wave, flood, you have precipitations as well as uh, many more drought, wildfire. So while we have this kind of hazards, that exposure assessment which is required to do this vulnerability and then take this assessment further to the interventions and the prioritize and plan based on the available finances. And that's how these 5 steps of climate resilience can work towards it. I would like to put forward how these 5 steps are getting enabled by GIS as a key player. Yes, on a GIS as a platform, as an integrator, which is help us to move further for collating the data, internally data, hydrometeorological data, and the data which is available in various forums. And once we have this data, what we actually working towards is enhance the climate analysis, creating the climate exposure assessment, and then visualization is, and that's how the precisely the climate hub will look like on the GIS platform, which is integrating, which is allowing to integrate various technologies from cloud computing, AI, towards various sources of data and the various sources of resources to bring the right interventions for today and the tomorrow in the area of the climate change. So we'd like to put across what when we're talking about the climate change, these are the 3 areas where the climate risk exposure, geographic sensitivity, and socioeconomic sensitivity works on. So every exposure sheet, which is having the various assets from populations, water, utility assets, the infrastructures, which is laid geographically on every hazard, which could be like heat wave, drought, flood. And once it being laid, this value of that hazard, that individual hazard, get assigned to that assets. And that's how the assessment being made as a exposure assessment. And then this how these assets being vulnerable towards the propensity of it, that various scenario being identified, and ultimately we reach to the risk aspect of it. And thus the GIS help us to, reveal the patterns, address the various risks from biodiversity loss to wildlife, wildfire, the various flooding across the time scale from today till future 100 years further, the drought in the area, how the rivers are meandering in the futures, and to mitigate that, what is the interventions are required today to minimize and bring the resilience to the systems. And uh, that's what the approach is. I would like to interestingly bring one aspect, how this climate change affects the woman as an integral part of our society. So it actually, when the recent study which talks about it, it not only works from the crop failure, fuel shortage, displacement, the civil war, it is actually loss of livelihoods as well as the lack of access to healthcare, and it impacts very high on terms of burden carrying to young and the sick and elderly, particularly in the women's sections of this. And so while these assessments are now moving in a hyper granular assessment, sectoral assessment are required, and that's what the GIS can help us to do, the hyper granular, hyper sectoral assessment, socioeconomic assessment for take the right interventions. And while taking these right interventions, the climate action pathways, as per the COP28, is race to resilience, race to zero, and wherein our recent work of ISRI Inc. working towards 30 by 30 California. It's a science-driven plan and global deal for nature, wherein 30% of terrestrial biodiversity and marine life intend to get recovered by or rejuvenated by 2030. And that's the plan, and wherein this climate change studies being carried out, where under the various climate information scenario, the scenarios like RCP, the representative concentration pathways of 4.5, 8.5 stands to be one of the high concentration pathways. And this is how the areas being can get compared. And once this risk being assessed, when this area has been identified on the comparative map, comparative, so interventions can be further prioritized and be get reflected. At the same time, the how the sea level could intrude in a San Francisco, if you can see here, at 25.8 feet, and if it is 100-year storm, which are the areas will get affected in and around San Francisco. That is being mapped across, and these maps are globally is available in public domain, as well as which are the areas can get infrastructure from socio-economic sectoral part can be get assessed. And this is how the GIS can enable the socio-economic strata, economic strata, as well as the environmental drivers for tomorrow. Further, I would like to take it to how this the populations in various areas can get affected, how housing unit can work it on. That's how entire mapping can be done. Further, ISRI Inc. Act work with Biden government, where climate mapping and for the resilience and adaptations is a climate exposure assessment tool being developed, which again I would like to showcase for this San Francisco, where various hazards, there's a 5 hazards being identified as a top hazards: extreme heat, drought, wildfire, flooding, and coastal indentations. Under every hazard, the hydrometeorological indicators, the data in being complied, is being compiled and common platform, and you can actually visualize it and sit, and then further can be used towards the analysis of climate change, the climate mitigation actions. And this is how the leaders, the government institutions can actually first and see how the end of the century, how the mid of the century, the things will look like, where the areas of interventions are required, and what kind of interventions are to be prioritized can be seen and can be worked upon it. And that's all the wonderful tool of this climate projections and the max exploration working towards its. At the same time, further, these hazards are also getting mapped under US communities every day. It's getting real time statistics, the map documentations, and it's big wildfire, it's we call drought, which is NOAA is actually providing supporting the data on this kind of platform. And it's become the public hub to share information, understand, and to participate, collaborate, to take the action, mitigate the actions, and I also have the stakeholder collaborations for the taking the right way of actions toward the climate change. And I would like to further move towards one of the urban hazard. This is urban climate assessment. I come from the biodiversity and the climate is the both combined in 30 by 30. Then hazards as a data sets as a hub being combined in CRMA portal. And then third is the urban hazard climate assessment tool, which is being done by the Thailand authorities, wherein the Bangkok flood is being mapped, and if you can see on the down, once the how much build area will get affected, how much crops area will get affected. You can see on the bottom with a forecast of 1.6 meter, 2.6, and the house vacant data will get affected. So this is the visualizations tool with 100-year basin flood simulations on the time scale can work it on, and it is available on the free domain. It is available for academicians as well as for the consultants, contractors to work upon working and see through it. The further you can visualize uh, for the community purpose how much flood they can expect in the future, and how if the actions not being taken, how much the assets and the socio-economic structure, the environment at the stakes, that they can understand with this kind of visualization, which help us to bring them together to adopt the climate mitigations for tomorrow. So this is what I would like to share with you, and I'm happy to answer the questions which come from them. Thank you.
Thank you so much, Suneet. That was fantastic. I really liked the dynamic visualizations you included in the presentation, and it really is amazing how many different purposes GIS can be used to evaluate climate change. So thank you so much for sharing.
Thank you.
I will save any questions for Suneet till the end. Till then, I'd like to introduce our next presenter. We have Brian Tucker. Brian is a Hawaii Conservation GIS professional working towards nature solutions for climate change with terraformation. He is a University of Wisconsin-Madison alum and a member of the Society for Conservation GIS. So thank you so much for joining us today, Brian. I'm excited to hear your talk.
Thanks so much for having me. I will share. All right, how is that?
It looks great.
Great. So I wanted to talk about solutions, natural solutions to climate change that we're trying to do. I mean, it's a huge topic, a huge problem, as we all know, and we're trying to solve this. I work with a company called Terraformation, and this is what we're working to do. So yeah, our mission is to restore the planet's forests, to capture carbon, revitalize nature, and build thriving communities. That's at the basis of what we do. And as you can see on this map, we're doing this globally. We're relatively new company, just started in 2020, and have these partnerships and projects going on globally. We're based in Hawaii, and we have employees across the world. So it's whole, consists of a Hawaii internal forestry operations. So we do our own projects at Terraformation. Plus, globally, we partner, with conservation organizations and various organizations to facilitate native forest restoration. And so, we want to help forest creators address the bottlenecks to scaling, because we need a lot of trees planted in the ground fast to counteract all of what we've been doing. In a relatively short time, we've pumped a lot of carbon into the atmosphere, and how are we going to get it out? Well, natural solutions, planting forests is one really great method. So in doing this, we've realized that there's a lot of bottlenecks to this. So, from early stage financing, finance seeds, tracking, training, there's a lot that goes into restoring a native forest. It's not always just as easy, go out, plant trees, you have a forest. Unfortunately, it takes a lot of work to restore landscapes. And so, that first part, that early stage financing is so key and probably the biggest bottleneck to landscape restoration. And so, we are in the business of developing carbon projects, because that's a great way to finance these projects and get them off the ground. And so you have your forest creators, and you have funders and organizations and businesses wanting to contribute to bettering our earth. And so it's not just about creating carbon, it's about creating biodiverse forests and supporting local communities. And so there's a lot that goes into this. And then, of course, we have an accelerator program that we're doing where projects wanting to develop carbon can apply, and we take them through this really great program to get their project, get them ready and prepared to implement these large scale restoration projects, and get those projects ready to go. And so that brings us next to seeds. Seed banking is a huge bottleneck. To plant trees, you need lots of seeds, and that is something that globally, we're short on, as our native forests begin to shrink, and the availability of seed is less. It's really imperative that we have a seed bank to grow our next forests. And so part of that is, how do we store seeds? And so that is a big issue, and we've developed a modular off-grid seed bank, and this is part of what we do as well. We've also been working a lot in East Africa to build this East Africa Seed Network, which has been really successful, and there's a lot of energy and behind this, and seeds are being collected and stored in this network of seed banks and being grown, and a lot of restoration projects are beginning as part of it. So this is great. Tracking, we have a software developing team full of software developers that have created this product TerraWare. It's free and available for anyone to use to track their seed, from their seeds to nursery to being planted out in the restoration projects. And so this is a great product that we have been developing and continue to develop. And then training, we have a Terraformation Academy. Some of our experts have developed these online trainings to help. How do you collect seeds? How do you manage your nurseries and so forth? And this is something that is continually developing as well. So providing all of these resources to really scale landscape restoration and really get through these bottlenecks. So how does GIS play into all of this? We have a small GIS team at Terraformation, and we support all these phases. As you all know, it's really crucial. And GIS is really crucial in project development, and then the support for the implementation of a project, as well as tracking and visualization. So I'll just share just a few examples. So, when we're looking at a project area, we have to, what is the restoration potential? What is the carbon potential of these landscapes that we want to restore? And so we have to use a combination of, globally available data sets, as well as just other remote sensing tools for the highest resolution imagery. This can be a challenge because a lot of these global data sets, not gonna lie, it's really, they don't always tell an accurate story about a project area when you get down to that local level. So we have to get in there with high resolution imagery and really there is also that manual of that manual activity of looking at the data and seeing how these global data sets compare with the what's actually happening on the ground, and working with partners to get even more information through geotagged photos, for example, and what are we seeing from above. So taking all of these tools and putting them together to see, okay, what's already forest, what's degraded land that can be restored, what's our restoration and carbon potential of this project. Or on the right, you can see just a standard slope map, taking these globally available digital elevation models and creating slope maps to see, like, okay, like for this particular area, it's in a mountainous region, and some areas, okay, yeah, we're going to do the native forest restoration, but there's also another component I didn't mention is agroforestry, very important to local communities, and those can be done at lower slopes. So, using these tools to see, okay, where can we fit in some agroforestry components to these projects. Drone imagery. I'm a licensed drone pilot too, and fly drone missions for our local Hawaii projects, and we can create really high quality orthomosaics, as you can see on the left there, and these support planning and how are we going to set up these restoration projects, and also you can really just take beautiful pictures of the landscape and surroundings as well when you have your drone up in the air. And so, yeah, it gets into the planning and organizing the implementation of a project, separating these projects into their various planting areas or zones and subzones is terms we like to use, whether you put a project on a grid or you use roads or other geographic features to separate your projects into their various areas. and the use of dashboards to track these projects of what's going on, how many plants have been planted, what species have been planted, where they've been planted. There's a lot of tools you can use with dashboards. Really great for visualizing a project. And finally, getting into cartography, sharing, these projects. And this is a combination of, this is a drone imagery of the project area, as well as, just the plants that have been planted and which species. So you can really bring these projects, to a greater audience. And with that, I want to say thank you. Feel free to get in touch. There's a lot of information there, but the nature of these lightning talks is you gotta get as much as you can in. But yeah, there's a lot that goes into each part of that, and we're just really happy to be helping make a difference. So thank you so much.
Thank you, Brian. Yeah, that was a fantastic presentation. I know it's always hard to fit enough information in, but yeah, that's really interesting. I had no idea, for instance, that seeds were such a bottleneck, which seems kind of obvious now, but it's really interesting to hear how many steps go into reforestation. So thank you so much for sharing with us. Okay, so now I will open it up to Q&A. I have some questions in the chat to get us started. So June, unless you want to come off mute and ask yourself, I can definitely read these out for you. Okay, I'm going to go ahead and read these out. So the first question is for Juan May. So Juan May, why did you decide to add place names in the north arrow, etc., using Adobe Photoshop instead of within the GIS package?
That is a great question. Thank you. The reason why we do that is because it's part of our standard workflow. We like using different GIS programs. So some people like to use ArcPro, some people like to use QGIS. And in order to have a standardized font and glows and all the things that makes our product when you look at it, even without our logo on it, it just makes everything standardized. And for the north arrow, we have a script in Adobe Photoshop where you put in the resolution of the imagery and how many pixels the imagery is, and the tool actually makes the scale bar for you, and it comes out exactly the same every time, so that you don't have to measure, 10 pixels from the border and stuff like that. And it's been the same way that we've done it for the last 25 years. Thank you.
Thanks so much, Juan May. Yeah, it's really interesting how much, normal GIS, how much you can customize using other programs, which I had never even thought about until I met Juan May for the first time, which is kind of a fun fact. Just learning how many different things can integrate with GIS while learning how many things integrate with GIS, how many different kinds of data. It's really quite fascinating. We have another question. This one's also from June for Brian. So Brian, why don't global scale data sets give us an accurate visualization of what is going on at the local level? Is it just a matter of resolution?
That is a great question, June. And something I don't really have a great answer for that. It's partially the resolution. You're talking about, most often 30-meter data sets, sometimes 10-meter data sets, but it also goes into the algorithms that are creating these. And so, our Earth is it's very dynamic. There's a lot of different things going on all over the place. So, if you've gotten into, machine learning algorithms and all of these things that are used to create these data sets, what looks like something in the imagery in one part of the world or in one habitat type or so forth looks different in another part. And so when you're trying to put everything into one, and categorize everything into something, that's just one example, thinking of like the global land cover data sets, for example, the way it picks things up. And then when you're talking about degraded landscapes versus healthy forests, it's easy, like if an area is clear cut, right? And that clear cut is fresh, you can see a distinction between, that area versus the surrounding forest. But, after 5, 10, 15 years, when regeneration is beginning, it's still a degraded forest, but it looks green, for example. And so it might be calling it a forest. And so there's just a lot of factors. And so you really have to get into, what's going on at that local level, and really connect with all of the stakeholders on that local level to find out, what's going on, what am I seeing. So yeah, it's I wish, when starting this, it'd be like, yeah, great, we can use these really wonderful global data sets and have the answer right there of knowing. And then we started overlaying it and looking at a local level and being like, this does not match. And maybe that's because we're spoiled with like Esri, providing this, really high resolution, half meter resolution imagery is their background imagery. And you have all of these other, imagery companies providing, this data, so you can really see what's going on the ground. And it sort of reveals like that doesn't match up. And then there's, you also time, when was that image or that data set produced? When was the imagery for that? So there's a lot of complex factors. I could go on, but I'll stop there.
Yeah, thanks so much, Brian. That really helps highlight complex GIS problems have complex solutions, and that's really the GIS story. So thank you so much for that answer. We have another question, this time for Suneet. So Suneet, what are a few ways Esri India is using GIS to tackle climatic issues in India?
Thank you for asking this question. In India, we are working with various state governments. We are working with various municipal corporations. So currently what you have in a climate assessment is a global scale models. You have coordinated regional downscale models. We at ISRI, what we helping users to downscale that model to the city level hyper granular assessments. And that's where the next level of climate change assessments are required. What we're doing is very global scale course model, which need to get percolated to the city level. And how's this climate change going to impact every sector, which is economic, the loss of biodiversity, it will tourism, if it is agriculture, water as a water security purpose, water available purpose. So that's how, these are the areas, these are the state department we started working on. Recently, we're working with Mumbai Municipal Corporations. It's one of the largest corporation in Mumbai. We are working with their multiple hazard vulnerability assessment studies for all the coastal infrastructure, what they've developed. So what is the vulnerability of that, and what are the interventions required for tomorrow that we are doing? So these are the projects we started working in India at state and the city level for hyper granular assessment. Thank you.
Thank you so much, Suneet. Sounds like you have a lot going on. So those sound like really impactful projects. So I can't wait to see how those turn out.
Yeah.
So it looks like we don't have any more questions. Any last minute questions here in the chat, or feel free to unmute yourself.
Madison, I think there's one more question for Suneet. Just
Oh.
upvote.
Oh, yep. Sorry, I totally missed a question. Sorry about that. Suneet, another question for you.
Yeah.
Morale asked, how much have governments accepted and utilized the information in managing the 5 hazards like drought or flooding?
Like drought and flooding.
Okay, drought and flooding.
Oh.
Okay, thanks. Yes, if you see the current central government projects, basically the federal government projects, which is coming under the National Plan for Climate Action Programs, wherein the drought and the flooding projects are being, the part of it for the initial assessments. And yes, there are huge uh, what you call infractions happening between technology players, consultants, and various local authorities to do these assessments. Yes, so drought is like there is a very in recent, if you see the climate change assessments are happening, there is a swapping trend. There is a flooding happening in most of the regions are experiencing the drought. In Delhi, even though there is no flood hydrometeorologically in the last quarter of it. But yes, Delhi experienced flood because of some other anthropologic activities. So that's how assessments are started coming up in various state and the central government.
Thank you so much, Suneet. So if there are no more questions, I think we're going to wrap up Q&A there and wrap up our, New Year lightning talks. I'm really glad all of you could join us, especially our presenters. Thank you so much for volunteering your time to share your expertise. We really appreciate it. And if you come back, we love a repeat lightning talk speaker, new topic every month. So you could come and just share a little bit more about different aspects of what you're doing. We really appreciate it. Next month, our topic will be geospatial big data. So if you know anyone or would like to speak about geospatial big data, super broadly, how you use it, your experience with it, even just cool stuff, about it, you don't have to work with it every day to be able to give a lightning talk, feel free to submit. And this recording will be available on the Women in GIS YouTube channel very shortly. So, there'll be a notification on our socials when it's all up. So our presenters can access it and you can send it to everyone you know. Thank you so much, everyone, for joining us today. That wraps up our January 2024 Lightning Talks. Happy New Year.